with Chris, our chief architect. Um, hey, how are you?
I'm doing good this morning. How are you doing?
I'm really fine. It's sunny outside actually and warm, and I see you with this thick.
It's not so warm out here. It's
Yeah,
a little bit cold.
yeah. No, it's warm, so I'm a I'm a bit more heat here than at your place. Anyway,
Mm-hmm.
anyway, back on topic then. Um, let's have some.
So one of the things I'd like to talk about is I was dealing with a client um, yesterday and helping them work through some design issues using events and they're a fairly large, implementation, and they're doing basically a batch process. And they were really struggling, and it's a struggle I hear a lot. Um, and I really want to talk about it because we were able to get to a real watershed moment by the end of the conversation. And so I kind of want to talk through that and get to that point of like, because I see people struggling all the time with this, and we had worked through some things about some application design, how you do event sourcing, and then they're having trouble with, well, how do we read all the data we need to process this fact, right? We get these events and we're constantly going back and reading data and reading data and reading data, and we're going to need to be able to read like Elasticsearch. We're going to need to be able to get that response data for possibly every single interaction that we do.
Yeah.
Um, and in my rule of thumb is that if you're having those kinds of problems, you're probably doing something wrong. You're
Yeah,
probably so if you need to read data all the time, you've probably forgotten something. And by what it means, your application has forgotten something. The biggest source of accidental complexity that I see in applications is the application knows something or the system knows something and then it forgets it. And then later on in the process, it has to rebuild what it already knew when it got started.
okay. Uh, yeah, I would argue that that's one of the good thing about event sourcing because you can rediscover stuff afterwards.
We can go and we can look at history, but if our job is to run a batch,
Yeah,
right? So
but
the standard process is they get a file in, they parse the file, and in the file they have a whole series of items they have to evaluate.
yeah,
They have a system that goes out and scans lots of other systems and pulls together data about every item, and then it goes and pulls that together and then sends it off to an ACL. It turns it into events. They go into event store and then they go and they do the evaluation of each item. And they got 4 hours to get the batch done. And the batch can have 3 million items in it.
okay.
Right? So, and the outcome of the batch can be not requested, right? So, an item which had been requested before wasn't in this file.
Yeah,
It can be um, no calculation required. So nothing changed that would require recalculation. Um, Calculation confirmed, i.e., we did have a change, but when they recalculated the value was the same as last time,
yep,
or new value,
okay.
right? And the problem is to do the calculation, you need data from all over the place.
Yeah,
So, and then not the other systems aren't always up to date, right? Because this is all flowing through. And so what they're finding is that each event that we broke this into would show up, and then they would have to do this giant query, and then another event would show up, and they do a giant query. So
over
they're
all
doing the
the over
right,
all systems.
right.
Okay.
Now some of them don't have a wide query, but some of them have a giant query,
Yeah.
right? And it's boom, and And if you look at the logical model, everything here is per item to calculate.
Yep.
But but there's a larger context. The item is part of the batch.
Yep.
Right? So what the system forgot was that when the file shows up, even though it's nowhere near where the calculation occurs, every single item when the file arrives.
Yeah.
So if we change this process to say, okay, when the file drops, send an event over saying batch started, items received. You can now create a manager in a stream and you can check off every item, right? And then, so now we can do a determinist result on each item. Say, oh, okay, well, it wasn't present. No calculation was required, right? Or I did a calculation, but then, so we do that, we identify which ones need to be calculated. And then we can send all the items that need calculation over the processor together. And it can calculate one query that gets the data from all the various systems. And then once it has all that data, it can spin up and calculate each one independently with what it needs from the data set that it just got.
Yeah.
So now we're not thrashing back and forth. So, and we also have an audit log of this batch. Right? So that's the accidental complexity, is by not knowing, by forgetting that you have a list of everything you need to do. You have to recreate everything and rerun it all the time. But if I know, here's everything I need to process, here's the ones that actually need work. Okay, now I do one query to Elasticsearch. I get all of my data back. And now I process each one of them. And I also now know when I'm done.
Yeah.
Because the other problem they had before was they didn't know when they were done.
How was it before? Because that I didn't understood really. So they had like this gigantic.
They were just doing it. They were doing it as every item was independent of any batch.
So there was this file, and they read the file, and per item in the file.
Right. So some other system would turn those into events, and they would send change markers on, over to the system. And so they were just reacting to, hey, this changed, hey, this changed, hey, this changed. And so the system is like jumping and thrashing because it doesn't know the context.
It's instead of accepting the fact that this is a batch processing and that you have some optimization capabilities that you have some optimization points of knowing this is what I need to do, or pre-process in the sense of, okay, this is the works that needs to be done on this kind of item, and in this case it's quite good because you can say I don't have any work or I have some work, and then only actually go to Elasticsearch in this case for all what actually
the broad data that they need, right? Because Elasticsearch lets you get really broad spanning queries all at once.
So, and there's one thing I don't understand. How do they know that this item or this line needs or doesn't need work? Where is this information?
So they have an input processor that gives them changes, and they evaluate the changes in material or not material.
Oh, okay. So this is pretty.
Yeah. So another system gives them the changes, and then they evaluate them. So one, were there any material changes? There were not any material changes. You don't need to bother calculating. So they can take those out.
Okay. More detail is probably a bit too close to the domain, and the real. It is a real case in this case, but.
So there's another aspect of this I really want to talk about that's also super interesting.
Yeah.
And that is, how do you figure this out when you're on the ground? And the approach I used to sort of go from this conceptual model that we just talked about to an on the ground, like, how do I do it? So I said, how would you do this if you're doing it on paper? If I had a sheet of paper on my desk and I needed to go into a warehouse, like suppose we're doing a warehouse and I need to know I'm doing inventory in a warehouse. So I need to inventory all of these items and I need to say, is the number the same and do I need to order more? Right? So how would you do that on pen and paper?
I'm allowed to go into the to the
Yeah.
warehouse.
Oh yeah. But
Yeah.
what would you do first? What's the
I,
first
I,
thing you would do?
I would check. Okay, this is. If I need to do the inventory, I would first check what do I know that has already changed to check
No,
that. No.
no.
Oh,
What's the very first thing you would do? Would you get a list of everything you need to check? Would you get a piece of paper,
yeah.
write down all the items you need to check,
Yes.
and then
Yes. Of course.
as you go through the warehouse, would you check them off on the piece of paper?
Yeah.
Like, oh, I checked this.
Yeah.
Oh, this one I need to order more, and make little notes
Yeah. Yes.
and
Yes.
walk around with your clipboard. So
Yeah.
this concept of how would I do it with a piece of paper, like that's what as a design thing, right? Oh, I need to go and check all these things. I'm gonna give myself a list. I'm gonna make little notes. I'm gonna check things off. That's the that's the
The,
batch stream,
the to-do
right?
list.
The to-do list, right? So what am I gonna do? I'm gonna get they forgot to make a to-do list.
Mm-mm.
They forgot to make notes on their to-do list of what they had done and what needed to be done,
Yeah.
right?
And this has manifested itself now. Did they had a problem before, or is this something that appeared recently?
Oh no,
Because
they're redoing a really traditional batch system to something that's event sourced and much more efficient,
yeah,
right? Because they want something that can do higher throughput. They want to do different things.
yeah,
So this is a new process they're implementing. It's an old process for their business. On what they were doing was they were copying everything every time between every system.
yeah,
So they weren't just doing deltas. They weren't checking to what had changed. They weren't. They would recalculate every one every time and push it to every system every day.
yeah,
And you can't scale if you're doing that. So this is about how do we create microservices? How do we optimize, right? And so as you're doing that, so and they didn't need the checklist previously because you ran every one of them, right? Their approach before was, I walk in the warehouse and I write them down as I look at the items, right? Because I'm going to walk the entire warehouse every time, right? But now we're like, okay, I think about it. I have a checklist. I can, I can then also, we can then also file my checklist as my log of I did the rounds,
yeah.
right? I remember I was a security guard at an amusement park when I was a kid, and I had this little box, and I had to go to every these places. There was a little key, you put it in there, and it punched the place on the log with time. So
Mm-hmm.
it proved that you were actually walking around and, and looking at
Excellent.
everything. And it creates this audit record of what you're doing.
Yeah. How did you cheat on that?
You didn't, you can't.
Sure,
That's
you
the whole
cheated.
point of it.
I'm sure you cheated some way.
So there's one more thing, another aspect of this that I also think is really important to understand about your data. And people are always worried about append only data sources being getting to be giant. And and I think this is another example, a really good example of this is prior they were copying everything every time. Now they're only copying the deltas and the changes. If nothing changes, they don't write down. But that gives them a problem without the checklist, right?
Yep.
In that they were like, well, we think we need to write down the changes each time, even if nothing changed, because we need a record that we did the work, right? And the problem is, if you think about your stream for the item, right, and it's got a calculation each time, right? You know, this is how many items were in the warehouse. This is how many items, right? But if it doesn't change, that's not actually useful information about that item.
Yep.
So by separating out the checklist of the work from the history of the, let's call it inventory item, we can be only put new changes that matter on the inventory item, but have a separate stream, which is the audit log of our process to check all of them.
Yeah. So that the stream design is you have inventory items,
mm-hmm.
A few millions.
Yep. Yes.
And then a series of
a daily
a
inventory
daily
check.
inventory check per day that only contains, okay, those are the items we checked today.
Right. Here are the items we checked today, and here's what we did. And so that inventory check, one might, here's what we found, and here's what we put, here's what we changed it to.
Yep.
We ordered more, we did this, we left it alone, no change was required.
Yep.
Because the thing is, if you put those changes in the stream of the inventory item, and so I have data, inventory check, data, inventory check, data, they're all mixed together.
Mm-mm.
I can't get rid of that stream. I can't extract that data. Every time I want to see the history of this inventory item, I also have to see the history of every time we checked it. Yeah. And those are two very different things.
Yeah.
So now, and honestly, we can archive off inventory checks, right, at a very different rate than we archive off the inventory. That inventory item might live for 3 years. I don't need every daily inventory check for 3 years to be in with that item.
Yeah.
So by separating them out, I really shrink my footprint.
Yeah, you shrink the footprint. You have archiving. I have a similar system, but before I tell that, it's batch oriented.
Mm-hmm.
Is that a requirement that it's batch oriented? That they need to for some imperious reason?
When the client sends a file, they have 4 hours to process everything on the file.
Okay, but they don't have any they don't have any choice. They get a batch of work to do.
Right now, so in this, another aspect here is very similar to sync over async. So I can take a reactive eventing process and I can create a batch on top of it. Mm-hmm. But if it's something is purely batch, I can't take a reactive event process and make it out of a batch process.
Yep.
Does that make sense?
That makes total sense. I still have a similar system, but who combines two things. It's about the work status of people working for government. Mm-hmm. And depending on certain things, we need to do some checks. And the thing is, we get twice a year a list of people who work for the governments, in what agency, what's their level, and some additional information. And the thing we do is, and that's batch oriented as well, is we send a list of people we know, and they come back with, okay, this is the information we have. And the first thing we do in that process is it's event source for the rest, but it's first make the diff between the two to just reduce the set of things we have to changes we have to check, and then we have an in place process that will reduce that list to anything significant, and we import that in one stream. It's like January import of civil or public servant. I'm never sure of the term. Is that civil servant or public servant? People who work for the state.
Either one is fine in the US. So civil servants are public servants.
Okay. And we do the checks, and then we have like this list of 100,000, I think, most of the time that's left, and then we send an update to the stream that correspond to that public servant.
Yep.
And the funny thing is, if we have a change there, then we have totally async checks that happens if this change has an impact on other processes. Right. But that's completely async there. And maybe of those 100,000, there's maybe 100 that needs to be, but there's downstream processing afterwards. But we do need that information in case they jump on. And that's from one source of information, but the other source of information is the public servant himself, who can change things in his resume. But that's completely, I mean, it doesn't change every day, and we have maybe 10 or 100 of people per month that change their resume, and where the significant changes again, and then the downstream processing. Right. But it's kind of this duality, and the nice thing is that batch import, after one or two of those batch, we just delete the old one because we don't need it anymore. We have the change we need. With some reference that says, we did that change, or we got this information from the batch of January 2021 or something. Just to keep it as a reference in the public servant stream himself.
Right, so that's what you want to do with the batches. You just don't want to forget that this is a batch, and you can know things about when are you done, that bringing everything together to do one list to go do the lookup. Yep. You don't want to break the batch into individual things. Like imagine if you did each lookup on each person as it came through, as opposed to collecting to do one query. Right. So that's keep your context with you. Don't forget things. Hang on to your context.
And that's inside that thing. And then for the outside processing, this is about mass recruitment and job selections and hiring. And if you're in a selection process, and we send a signal that says on the public servants information side, like there is a significant change, and that's the only thing we say from that part of the system. We just say something happened that is important, and then the downstream just say, okay, something happened important for, let's say, Yves. Do I need to do something with Yves? Nope, I forget that.
Right. And so the keys are model your process. If things are getting complicated or things are getting expensive, make sure you model your process, make your checklist, work your checklist.
Yep.
Everything should be a deterministic process.
Yep.
If it's not, or if you're worried about my throughput or my reads, or I'm doing lots of things, your first step should be, am I making this too complicated? Have I modeled my process? Do I have my checklists?
Yeah, and that's an interesting one, because that's a change. That's something they could permit in let's say the way they did before, but they probably had. That's a guess I'm making. They probably had also, if they looked at the processing, the full processing, they already had some inefficiencies there, but they were hidden.
Well, no, it wasn't hidden. It was pretty obvious, because they ran everything from this system to this system, everything from here to here, everything from here to here.
Yeah.
So moving terabytes of data everywhere, every day.
Yeah. Okay. And then they took exactly the same process, thought, oh, I'm going to event source that, and it's going to solve.
Well, no, what they did was they took that process and they broke it into events, and they understood, okay, well, They don't have to be all together. We're just going to turn these all into events. But the step that was, they got to places where they started breaking that down, creating event streams, processing the streams, but then they found themselves thrashing because the events were all without context.
Yep.
Every event was, so you microservices need to be independent in their processing, but your process still needs to have a context for when you do that. So, by waiting till we were done with the whole list, we now know, okay, we're done. So if you're thinking about it, if you're processing 50 items, 100,000 items, sure, whatever. But if you're processing, doing like 4 batches of 3 million items, right? Knowing that, hey, a file dropped, a batch has started, and it's 3 million items. It lets you go warm up your Redis cache, right? So you can take all those items while you're waiting for everybody else to do the work, bring them all into context. So now your checks are really fast, right? Because everything's in your Redis cache, it's right there. And then when you get to the last one, you're like, okay, this batch is done. Flush the cache. When the next file drops, oh, okay, go get all this and bring it up. So now you can optimize your resources. And now I don't have to say, oh, we've got 120 million items. There's no way we could cache that. Yeah, but they show up in batches of no more than 3 million.
Yep.
Right. And you have to answer 4 questions. Can you write a cache that gives you just the information you need to answer 4 questions on 3 million items quickly, if you know which items you need to check? That is a much more practicable problem, right? Than, oh, I need to know everything, even just I need to load all of these and all their history. No, you don't. It's like, what are you doing? At this step, I answer 3 questions, then I know whether or not there's material change. Okay?
Yep, that's cool.
1 second. So, yeah.
Nice. That's actually designing systems and yeah, the to-do list. So there's a lot of people who forget the to-do list. I forgot it. But that's and I do have a to-do list. uh, so that's natural. And there's a lot of work that can be done. But I guess a lot of people think, okay, I can parallelize things and so on, but actually just having a to-do list, making it more.
Well,
Don't.
the to-do list is what allows you to parallelize
Yeah.
with context. Because what I do is I have my to-do list, I take every item on the to-do list, and I send it out to be done. And when it comes back, I check it off. But if I try and do all those items without that checklist as a context, I don't know when I'm done. I don't know when I'm starting. I can't coordinate my larger system to know what stage of the process I'm in. So if I know I'm in this stage, I know I have this list, I can set things up to be easy.
Yep.
Right.
Yep. And it's totally a system design and a stream design and probably some kind of event model design that we should also talk about one day.
All right.
All right.
All right. So so the summary is that when you find yourself querying a lot and saying, how do I scale this? And things start to get complicated, right? Every good event source system should be an assembly of simple components that work together. And if it becomes something other than that, then you should model your process. Processes are very good as to-do lists, and you should optimize for the concrete step that you're in. So it's a code smell, it's a design smell to be going, oh, I don't have enough data. Oh, I've got to go and do these giant queries. It probably means you haven't set up your process correctly.
Yep. Cool. Noting that.
All right.
Okay. I think we're done on the subject, I think.
Yes.
Cool. Thanks.